Okay, so here we need to explain the concept of finding the angle in between two given planes. So here we need to understand that suppose if two planes are given, two planes, so they will have a common line of intersection. So we need to find the angle in between these two planes, that is theta. So the angle in between the two planes, it is same as the angle in between their normals. Suppose this is the plane pi1 and this is the plane pi2, and the normal vector to the plane pi1 is n1 and the normal vector to the plane pi2 is n2 vector and n1 vector. So then if this angle is theta, then this angle will also be theta. It means the rule is that the angle between two given planes, angle between two given planes is same as the angle between their normals, angle between their normal vectors. You can see angle between their normal vectors. So this rule we have to use. So it means, suppose let's say that the equation of the plane pi1 in the vector form is given as r vector dot n1 vector, that is equals to d1, and the equation of the plane pi2 is given as r vector dot n2 vector, that is equals to d2. Then the angle in between the planes, therefore the angle between their normals, which are n1 vector and n2 vector, that will be same as the angle between angle between the planes pi1 and pi2, angle between the planes pi1 and pi2. So that is theta. Let's say it is theta. So that will be equal to the cos inverse of n1 vector dot n2 vector divided by magnitude of n1 vector n2 magnitude of n2 vector. Simply we know that n1 vector dot n2 vector, that will be equal to magnitude of n1 vector into magnitude of n2 vector into cos of theta, where theta is the angle in between the vectors n1 and n2, which is also same as the angle in between the planes pi1 and pi2. So therefore theta would be simply equal to cos inverse of n1 cap dot n2 cap. So that will be nothing but n1 vector dot n2 vector by magnitude of n1 into magnitude of n2. So we can find this in the Cartesian form also. Suppose if the equation of the plane pi1 is given in the Cartesian form, we need to find one formula in the Cartesian form. So suppose the equation of the plane pi1 is given in Cartesian form as ax as a1x plus b1y plus c1z plus d1, that is equal to 0, and the equation of the plane pi2 is given as a2x plus b2y plus c2z plus d2, sorry, we should write capital D2, plus d2, that is equal to 0. Then, so therefore the normal vector to the plane pi1, that will have the direction ratios a1, b1 and c1. So it means n1 vector can be written as a1 I cap plus b1 j cap plus c1 k cap. And similarly, the normal vector to the plane pi2 will have the direction ratios a2, b2 and c2. Therefore n2 vector, which is the normal to the plane pi2, that can be written as a2 I cap plus b2 j cap plus c2 k cap. So now therefore n1 vector dot n2 vector, so that would be equal to, obviously we have to take the dot product of these two vectors. So that will be a1 a2 plus b1 b2 plus c1 c2, and magnitude of n1 vector, so that would be equal to square root of a1 square plus b1 square plus c1 square, and magnitude of n2 vector, that would be equal to square root of a2 square plus b2 square plus c2 square. So now, therefore, uh, the angle theta in between these two planes pi1 and pi2, that would be equal to cos inverse of, actually we need to take the magnitude of this, since if two planes will intersect, then one acute angle is also formed and one obtuse angle is also formed. So if theta is an acute angle, if we need to find the acute angle in between the two planes, we so suppose we need to find the acute angle in between the two planes, then cos theta will have positive value only. So we need to find the mod of this. We need to take mod of this actually. We need to take mod of this. Okay. So therefore here cos theta, we should write it as magnitude of n1 vector dot n2 vector divided by magnitude of n1 into magnitude of n2. Okay. Since theta, we need to find the acute angle in between the intersection of the planes. So here also cos theta, cos inverse, we should take the mod of is the absolute value of a1 a2 plus b1 b2 plus c1 c2 divided by square root of a1 square plus b1 square plus c1 square into square root of a2 square plus b2 square plus c2 square. So we can understand this concept by using one solved example. So here we can see that if mm, so here we can have two special cases, some special cases. So the special case one is that if the planes pi1 and pi2 are perpendicular, means if plane pi1 is perpendicular to pi2, then their normal vectors also will be perpendicular, means n1 vector also will be perpendicular to n2 vector. So it means n1 vector dot n2 vector, that should be equal to 0. It means what? We can tell that a1 a2 plus b1 b2 plus c plus b1 b2 plus c1 c2, that should be equal to 0. So this is the condition for two planes to be perpendicular. So this is the condition for this. Also we can use as the required condition, and this also is the required condition in the Cartesian form for the planes pi1 and pi2 to be perpendicular to each other. So now then the special case 2 would be that if pi1 is parallel to pi2, it means that the two planes are parallel to each other, then n1 vector also will be parallel to n2 vector, means their normal vectors will be parallel to each other also. So it means that their direction ratios should be proportional. So it means that the direction ratios of the normal vectors, the direction ratios of their normal vectors, which are n1 vector and n2 vector, so that should be proportional. So their direction ratios should be proportional. Therefore, it means that the ratios of a1 and a2 should be equal to the ratio of b1 and b2 should be equal to the ratio of c1 and c2. So this is the required condition for the planes pi1 and pi2 to be parallel to each other. To be parallel to each other. So we can understand this by one solved example. So suppose one question has been asked, that is, that find the acute angle between the two planes, which are given as 2x plus y minus 2z, that is equal to 5, and 3x minus 6y minus 2z, that is equal to 7. That is equal to 7. So now, therefore, here the normal vector to the plane pi 1, let's say this plane is pi 1 and let's say this plane is pi 2. So therefore, n1 vector, that would be equal to 2i cap plus j cap plus minus 2k cap and n2 vector, that would be equal to 3i cap minus 6j cap minus 2k cap. Then so their dot product n1 vector dot n2 vector, so that would be equal to 2 into 3, 2 3 is 6, then plus 1 minus 6, that is minus 6, then plus 4. So that would be equal to 4. And magnitude of n1 vector, so that would be equal to square root of 2 square plus 2 square plus 1 square, so that would be equal to 4 plus 4, so that is 9, so that is 3. And the magnitude of n2 vector, so that would be equal to square root of 3 square plus 6 square plus 2 square, so that would be equal to square root of 9 plus 36 plus 4, so that is 49. Square root of 49, that is 7. So therefore the required acute angle between the two given planes is given as is theta, which is equal to cos inverse of n1 magnitude of n1 dot n2 divided by magnitude of n1, means mod of n1 dot n2 by magnitude of n1 into magnitude of n2. So that would be equal to cos inverse of mod, this is 4, so that will be 4 by 3 into 7, since n1 magnitude is 3 and n2 magnitude is 7. So therefore the required angle theta, that would be equal to cos inverse 4 by 21. So this is the answer. Thank you.